Hello everyone, welcome to V4. I am Kamal. In the series of number system, we are going to continue with highest common factor. In previous video, we discussed about how to find highest common factor and we solved few important questions. So this is the last video of highest common factor. Let us start this video. So in this video, we are going to discuss only two questions, but these two questions will have good amount of concept. Yeah, obviously there is a direct way also. We'll discuss how to do it traditionally and then directly by using formulas. So just I'm going to discuss only two types of question. Both the types of these questions are very important. Let us start our video. How many sets of different factors of 72 are co-prime to each other? So always remember sets means pairs. How many pairs of factors of 72 are co-prime to each other? What is my co-prime? If two numbers, the highest common factor is 1 means I can say these two numbers of co-prime, which means let us consider there are few factors for 72. First, we will identify how many factors for 72. 72 is nothing but 2 into 36. 36 is nothing but 2 square into 3 square, so it will become 2 cube into 3 square. So total number of factors is equal to 4 threes are 12. There are totally 12 factors. Out of these 12 factors, how many ways I can select two pairs such a way that both the and the highest common factor for that pair of factors is 1. That's what the question is all about. So we should find two factors. I'm assuming two factors as A and B such a way that these two factors highest common factor should be 1. I am assuming one factor of 72 as A, another factor for 72 as B. So, since 72 is having only two prime base, one is 2 and 3, I am also assuming that A is made by uh, the same 2 and 3 prime base. Here I am considering A, it is B, B cube. Now, the thing is, I have to identify such a way that the highest common factor of 2 power A, comma 2 power B should be 1, and the highest common factor of 3 power P and 3 power Q should be 1. Because if I'm talking about highest common factor as 1 here means here the two numbers are made by only two prime bases. If the prime base's highest common factor is 1, it doesn't matter the power. So everything included. So if it's two powers and another numbers two powers, highest instead of finding the highest common factor for A and B as 1, I'm taking the individual prime basis numbers, two powers here and two powers here. If this individual highest common factor is 1 means obviously automatically the entire number's highest common factor will be 1. So this is what we are going to do. So A and B. The minimum value of A and B is 0 and maximum value it can take is 3, which means it can take all the values from 0 to 3. 1, 2, 3. Similarly, it is for P and Q also. So for P and Q, start from 2, 0 to 2. So the values it can take is 0, 1, and 2. These are the values this A and B, P and Q will take. Okay. So first, always remember in aptitude, if it is and means multiplication. Yes, we discuss in permutation combination, but remember AND means multiplication, OR means addition, OR means addition. Here, I'm going to find all the possibilities for A and B so that my highest common factor should be 1. And with this, all the possibilities, if you multiply with this, all the possibilities for P and Q, such a way that highest common factor is 1, I'm going to get total number of A's. Okay. So, So in this question, this is method one of solving this question. So next slide, I'm going to discuss method two of solve this question by using direct formula. But you should know how we are solving this. Then you can use the direct formula also. So the thing is, if a equal to 0, we can also 0. Yes or no? If it is a equal to 0, b equal to 0, 2 power 0, is 1. Again, 2 power 0 is 1. So highest common factor for 1 1 is 1. Similarly, if a equal to 0, which means if 2 power 0 is 1, then b can take all the values from 1 to 3. Still the my highest common factor is same. So no, 1 comma 2 is 1. The highest common factor. I'm talking about highest common factor. 1 comma 4 is the highest common factor is 1. 1 comma 8 still the highest common factor is 1. That's why it doesn't matter for power of b. If power of a is 0, because power of a is with 2 power anything, so 1 is coprime to all the numbers. That's why again, if b equal to 0, similarly a can take all the values from 1 2 3. So here we have one case. So here three different cases, here also three different cases. 1 plus 3 is 4, 4 plus 3 is 7, totally 7 cases. Now I'm going to find the same thing for p and q. P can take minimum value as 0. So why I'm taking 0 for a and b instead of other numbers? Because if a equal to 1, it will become 2. If b equal to any one of the values like 1 2 3, it will become some 2 powers. So eventually the highest factor common factor is never going to be 1. It's going to be some other value. So if I make one number as 1, then another number as something else, still my highest common factor is going to be 1, because 1 is co-prime to all the numbers. If p equal to again 0, q can take all the values from 1 and 2. So that still the highest common factor is 1. It's the same for when q equal to 0, p equal to 1 and 2. So here total number of cases 1, here it is 2, again here it is 2. So 1 plus 2 is 3, 3 plus 2 is 5. Total 5 cases. So total number of cases, total cases, it's nothing but 7 5s are 35. Here the problem is I am assuming a and b as two different numbers. Yeah, that's true. But the power in the question, it's an unordered pair, which means there is no variable is mentioned. If it is variable mentioned, order is important. Since the question doesn't mention about order, which means I have to remove the order. How to remove the order? Just here, out of 35 cases, if I subtract uh, here, these two cases are same. Yes or no? If a equal to 0, b can take all the values. If b equal to 0, a can take all the values. These two cases are same. Instead of taking it as two different cases, I'm going to consider it as one different case. Similarly for this also, instead of taking it as two different cases, I'm going to consider one different case, because it's an unordered pair. Order doesn't matter. Both the for both these results, the order is same. It is 1 1. So 35 minus what are the values? I'm going to subtract 1. Why? Because 1 is a equal to 0, b equal to 0, and p equal to 0, uh, q equal to 0. In that case, it will become 2 power 0 into 2 power 0 as a will become 2 power 0 into 3 power 0. B will become 3 power 0 again 2 power 0. Eventually it will become 1. Eventually it will become 1, 1, 1. So here the question says different factors, but for these two cases, since it is not repeating cases, but the factors are same. That's why from total number of cases, I'm eliminating the case where factors repeat. If I divide by these two, I will get only unordered pair values. Okay, 35 minus 1 is 34. 34 by 2, the answer is 70. So let me explain this. I hope you understand this. The total number of factors is 12. So out of these 12 factors of 72, if I take any two number factors, the highest common factor of these two numbers should be 1. That's the important case. The second thing is, I hope you understand everything about here. I'm assuming two different factors as A and B, and all two different factors of A and B are made by only two prime bases. One is 2 and 3, because 72 is made by 2 and 3. Okay, if it is made by three factors, we just need to take three factors. Based on the numbers only, you have to assume this first thing. And second thing is, my aim is to, instead of finding the highest common factor of A and B as 1, I am focusing on individual prime basis fact numbers, 2 powers and then 3 powers. If 2 powers and 3 powers of 3 and these two different numbers, if it is 1 1 means, then which is equal to finding the entire highest common factor of two different numbers as one. So that's why I'm focusing on each one. So the total number of ways this 2 power a and 2 power b, the highest common factor of these two number one is totally 7 ways. For this, totally 5 ways. Totally 7 5 are 35 ways. But the problem here is, since the question is unordered pairs, we are focusing on ordered pair because these two cases are same. Just because we have two different variables, we are considering it as two different cases. So in order to eliminate, instead of assuming as two different cases, I have to assume one different case. How to do that? Total number of factors by two. But the problem is, since the question is asking about different factors, when a equal to 0, b equal to 0, and p equal to 0, q equal to 0, the both the value of a and b will become 1 and 1. So from total number of case, first I am subtracting the case which is not required based on my answer. That is 34. Out of this 34, my duty is to eliminate all the cases, okay, uh, which are repeats two times. That's why I'm dividing by two so that I will get the answer which repeats exactly only once. Okay, so this is the method one of solving this question. What is method two of solving this question is, for example, any number, if it is in the form of some p power a into q power b something, if I want to find how many ways a pair of factors of n is n factors of pair of n is having HCF as 1 or coprime, either way same. So though first I'm talking about for ordered pairs. So for everything first you have to do means, so first you know total number of case. Total cases is nothing but 2 2 times of a plus 1 into 2 times of b. So it's plus 1 into, it keep on goes based on numbers for ordered. I have two different cases. One is different factors, one is non-different factors. So total number of factors for this is uh, total number of cases. It's nothing but the same thing. 2 power a plus 1 into 2 power b plus 1. It keep on goes. It's into, okay. Here total cases is nothing but 2a plus 1 into 2b plus 1. It keep on goes. So finally I have to minus 1 because it assumes two different numbers are same when these two cases are alone is possible. Okay, for unordered, minus for different, other one is different non-different. So total number of cases nothing but, or if it is difference means, so 2a plus 1 into 2b plus 1 minus 1 divided by 2. And total number of cases is nothing but, if it is non-different, 2a plus 1 into 2b plus 1 by 2. Sorry, here for different only minus 1 should be there. Here there is no minus 1. The total number of value minus 1. Okay, it is not minus 1 for you. So these are the two different ways we can find the answer directly without doing this manually. But this is how we do the manual way of solving this question. Okay, let us move to next question. How many different factors of 2000, okay, 21,600 have the highest common factor of 45? So here first I prime factors 2016. Here also they are mentioning different factors. So sometimes if they doesn't mention whether the highest common factor of two factors should be one or three factors should be one, it is implied that we are talking about only two factors. If it is more than two factors, they will specifically mention how many ways I can select three different numbers, the highest common factor as 1. If it is they are not mentioning means it is understood that it is they are talking about only two factors. So 2000 21,600. I can split this as 216 into 100. 216 is nothing but 6 cube. So 100 is nothing but 10 square. 6 cube is 2 cube into 3 cube. 10 square is 2 square into 5 square. Eventually the number will become 2 power 5 into 3 square into 5 square. So how many different factors of this 21,600 have the highest common factor of 45? What is the prime factorization of 45? It is 9 5s are, which is equal to 3 square into 5. So I can split this number as 3 square into 5 into 2 power 5 and 3 power 1 into 5 power 1. Now, if I find the total number of cases for this bracket, I can say that all these numbers will have a 45 as multiple. So here, since they are talking about unordered because variable is not mentioned and different case. So first I will find total cases. Total case is nothing but 5 into 2 plus 1 into 2 into 1 plus 1 into 2 into 1 plus 1, which is 5 2s are 10, 10 plus 1 is 11. Again 2 1s are 2, 2 plus 1 is 3. The same thing here also 3. Totally 99 cases. Since they are talking about different formula is total case minus 1 by 2. Total cases 99 minus 1 by 2. It is nothing but 98 by 2. 98 by 2 is nothing but 49. 49 my is my answer. With this, I'm going to stop this video. I hope you understand this video. Thanks for watching.